and welcome to the second in a series of videos regarding barcodes and their uses. I'm Wayne Johnson of FIDA Solutions, and in this video we will go through the most common issues that are associated with printing and using barcodes, especially in the food industry. An overview would be print quality, so things like smudge, ink, bleed, physical damage of the barcode itself, scratched or parts missing, magnification of the barcode when it was first generated, the colours that can be used on barcodes, and the checksum digits, whether they're incorrect or correct. So to go into some detail on each of these, so print quality. The print quality needs to be crisp, and especially on the type of substrate that it's being printed onto. So things like film, packaging, or outer cases, or whether you're printing onto a label before it's then applied to an outer case. So things like smudge or ink bleed or partially printed barcode affect how effectively it can be scanned by ID readers or scanners as it goes through a system. Smudging is usually when the barcode has just been printed and then it rubs against a barrier, a side, and therefore smudging the 1D barcode information, the bars, the lines, etc. Ink bleed is often seen when you print directly onto an outer case. The outer case cardboard that you actually use needs to be of a certain type, grade A board, which will actually stop the amount of bleed that goes into the cardboard from the ink. Also, the type of ink that is used is very important. If you go for lower grade board, it's very cost effective for the product that you may be producing. The problem is if you print directly onto that, a lot of the barcodes that you may print may not be able to scan in depot, in store at a later date. So it's certainly something to look at, and it may be an option that you actually print onto a label and then apply those directly to the outer case instead. So it all depends on the cost saving that you're actually looking for. Partially printed barcodes can often be where a print ribbon is running out, ink has run out if you're using an inkjet printer, for instance. But one thing to also look at is damage on a print head, especially on the thermal printers, which are predominantly used for film or direct label print. What can happen is the way they actually print the barcode is you put an electronic charge creating heat across the print head, which has small pixels. Those pixels then create the dots which actually produce the barcode or print information. If those pixels are damaged or burnt out, then what you can get is thin lines through a barcode. These are exceptionally bad for 2D barcodes or 1D barcodes. So on a 1D barcode you may see very thin lines through the barcode. If they're along the whole extent of the barcode, then the barcode may still be read as long as the bottom portion or top portion or big portion of that barcode can still be scanned. A problem comes if it actually goes vertically down one of the black lines, because the problem with that then means that it splits that solid black line into two separate lines, which actually produces an incorrect barcode or non-valid barcode that won't be able to scan through the system. Physical damage is where parts are actually ripped, torn through that barcode, extremely scuffed because it's been through a long conveyor system. There's physical damage on the line which is trapping that barcode, therefore parts might be missing. 2D barcodes are much more robust on this, and you can actually take a corner off a 2D barcode and it will still scan. 1D barcodes though, EN8s, 13s, 1 to 8s, etc., are more susceptible to damage, and therefore won't scan through the system. When you're first generating a barcode to go onto your packaging or go onto your outer case, one important part is making sure that the magnification is correct. Usually there's a minimum of 80% magnification that retailers will accept. If you start to go less than that, or you stretch the barcode when you're actually making it fit within the design, what you could be doing is actually stretching and elongating the actual bars associated with that barcode and making it a non-valid barcode. It's i.e. it won't be able to scan or read through the system because the bars aren't the correct widths and the gaps aren't the correct widths for the system to actually see. So be careful when actually creating or copying barcodes across. Colours of barcodes are exceptionally important. There are certain types and colours that can be used for the background or the barcode itself. Examples can be seen. A real most important one is that red or orange barcodes can be extremely difficult to scan, especially if you're using a laser barcode, so a red line through the barcode, or you're actually using a vision system but actually uses red lighting to illuminate the barcode while it's being read. The reason for that is when the red laser hits that red or orange barcode, it actually blinds the reader itself, and it can't actually then distinguish what the laser or what the colours of the barcodes are. So always try and steer clear of a red or orange barcode if possible, or look at different alternatives. When you're actually looking at barcode design as well, especially when you're using a 2D barcode, there is a possibility to what's called an inverse code. So it doesn't always have to be a black barcode on a white background. The way that most 2D cameras actually read a barcode is they actually use it in the grayscale, and it's the contrast between the two. So a lot of them actually running black and white, and it's the darkness and the lightness contrast between the foreground or the barcode and the background itself that allows it to see and read. So therefore, if you've actually got a piece of packaging which, say for instance, has a solid red background and it's a Christmas packaging, then what you could do is put the 2D code as a white barcode instead. And what you could then do is actually hide that between, say, snowflakes on the packaging design. So there are ways that you can actually look at it. It's not just a black on a white background design that can be used. And I've added some examples here for you to look at. When a barcode is actually generated, the last digit, especially on a 1D barcode, is called a checksum digit. What that does is an algorithm which checks all the other digits within the barcode and then creates the checksum to make sure that it's a valid barcode within the system. Some of the main errors that I have seen is either that checksum is actually missing, the checksum hasn't been calculated correctly through a calculator system, it's actually been just added on the end by somebody who thought, oh well, that must be the correct check digit, or it's been set as static. And the problem is, if you've copied a barcode across, or you've just added that number thinking, oh, that must be correct, it then invalidates the whole of that barcode. Therefore, if you're running it through a system, you may be getting issues with it not being able to scan. The first point of call is if you are getting on a line, barcodes not being read and you believe it's correct, go on to a website verification system, and I've added some details below. And what that will allow you to do is actually put in that barcode and then calculate the check digit that should be from that. In my experience, when I've had these issues, that's the first point of call I would go to. and actually check and make sure that the barcode that I'm actually trying to use and have been given, maybe it's from development, maybe it's from the retailer, that it's actually correct and it is the barcode that we're actually looking for. I've actually had systems as well that on some systems the printer is intelligent enough to actually incorporate and check the check digit and generate a check digit itself, therefore prints quite happily with an incorrect barcode at the start because it does the work for you. It calculates and generates it correctly. Other ones though aren't intelligent enough to do that, and they will just print what you have put in. So on one particular site they were actually printing both offline print and online, and we got a call. I went to site and they were two different barcodes. One system, which was inline and scanning, was actually stopping and rejecting, while the other system, which was being printed online, was still running okay. And the reason being is because that printer and the way it was controlled was altering the check digit itself. So one thing to check and be careful. Missing numbers within a barcode, especially EAN 13s, ITF 14s, or EAN 128s. They're the most crucial. ITF and EAN 13s, usually it's because when you're first issued a barcode from a retailer, from the development team, from marketing for instance, they often put it in an Excel spreadsheet. And the problem with an Excel spreadsheet, it usually doesn't accept zeros. And so what happens, the leading zero is often stripped off and therefore doesn't actually show when that's handed over. I've been handed over barcodes, you have a look at them, start typing in and think, well, there's a number missing. Do you then assume that the number is a zero and add it on? Or it could be the check digits that's missing. Always make sure. So if you've only got 12 numbers and it should be an EAN 13, so i.e. 13 digits, or if you only have 13 and it should be an ITF 14, so 14 digits, go back and check. Don't assume, because then that could be wrong and very costly. EAN 128 barcodes, the best thing to do is check on those. Is EAN 128s have what they call application identifiers. An application identifier is the number at the start of the barcode which is in a bracket. So if it's a bracket 1, you will actually see that's the application identifier for the code itself of that particular product. If you actually see an application identifier of 15 or 17, then that's the date code information associated with that product. What often happens, especially when scanning, is that if your system has been set up to look for an EAN 128 with a 15, so a display until date code within it, but what you've actually put within that is a 17, which is actually a best before date. Those two dates could be the same, but the barcode itself is now different because it's now got a 17 instead of a 15 within it, and it will scan incorrectly. So the application identifier, the 15 or the 17, is extremely important within an EAN 128 barcode. You need to make sure that that is correct and is scanning correctly before you start. Also make sure that the date code itself hasn't been set to a static, because what will happen is if it's been set to a static, the first numbers that you type in for the date code will be the ones that you always produce on any production run, and therefore the date code within that barcode is now incorrect, and it will then, if you're scanning, it will then scan incorrectly and alarm or stop the line, and you will then be looking at that barcode, which has happened to me many a time, and wondering why there is a difference and why it's wrong. And usually it's if you actually generated those barcodes on an offline system and then brought them to the line, that's usually it's either been set to a static or it's been set to a wrong date format. So definitely check on that. Systems not updated can often be a problem as well, and that can be internal systems, but could also be retailers' own systems as well. I've had it in the past where I've received a barcode. That's the barcode for a brand new product. Absolutely great. All the packaging's been produced with that barcode. That happened to be in EAN 13 barcode. All the packaging's been updated. We've generated the product, but before we actually started a production, I actually took that barcode into a store to have it scan through their system. What we actually found, that when it was scanned, instead of fresh pasta, I was actually being told it was black boots. Now, that means that the retailer's system at that point of checking hadn't been updated with the new information for that barcode, and they had reused previously used barcodes. Now, that's not a problem as long as their systems, so the databases in behind, have been set up. The reason why they reuse barcodes is because they pay for those barcodes so that there's only one in circulation at any one time. So therefore, if they're no longer going to produce that particular product and it's not going to be run on that barcode, they can reallocate it within their systems to use. So they're the main points on incorrect, issues with barcodes. So again, just to run through things to check: print quality. Are you actually getting a satisfactory print on the barcode? Is it smudged? Is there ink bleed? Is there partly printed information, which can actually affect the readability of the barcode? Is there physical damage being caused, either when it's initially printed or as it goes down the line? The magnification of the barcode that you're generating, is it actually correct? The colour, make sure that the colour is correct when you're actually doing printing the barcode, and trying to avoid red or oranges. Check some digits are correct. So make sure that the check digit, which is a crucial part of the barcode, is actually the correct number for the barcode that you're trying to produce. Because if it isn't, it won't scan. And there are systems online that you can check the checksum digits. Missing numbers. So missing numbers completely. And whether that's a leading zero, whether it's an end part, or whether it's date code information which has been set as a fixed text. And systems not updated. So retailer systems or internal systems that haven't been updated with that barcode on that particular product. Please join us for the third video in the series, where we will actually go more into depth of what's the difference between barcode verification versus validation. Thank you.